they can give you a question based on that. Okay, fine. So let's begin by talking about differentiation first. The first thing which can be asked in differentiation is going to be the formal definition based on the limit approach. Based on the limit approach, differentiation ka definition f dash a is limit. So what is f dash a? How the function is changing, right? Say suppose I want to ask how the function is changing when x is equal to a. When the function fx, in that function x is equal to a, mane I draw a function and here I take x is equal to a. This is different values of x. Now when x is a, then what is the, in a way, what is the slope of this function? How this function is changing, that is the derivative. So through the limit approach, agar hum limit approach ki baat kare, then f dash a is limit h tends to 0, f of a plus h minus f of a by h, right? This is also called as measuring the instantaneous change or instantaneous rate of change of a variable. Okay, so that's the first thing which we should know. Ki we are trying to go ahead and we are trying to ask how the function is changing, the rate of change of function divided by this h, right? Now, if the derivative of the function is greater than 0, we can say that the function is increasing. If the derivative of the function is less than 0, we can say that the function is decreasing. And if the derivative of the function is exactly 0, then we can say that at this point, the function can have maxima, minima, or point of inflection. So usually whenever we have to go ahead and we have to find maxima or minima, we will go ahead and we will we will find the differentiation. We'll do the derivative of the function and equate it to 0. इस case में we need to know the graphical implication also, which I already wrote here, that graphically the slope of the tangent at a point, right, that is basically the derivative of the function. हम क्या कर रहे हैं उसमें, हम उसमें जाकर उसका slope निकाल रहे हैं at any point. That is what we are trying to go ahead and do. फिर कुछ बेसिक रूल्स है हमारा डिफरेंशिएशन का. आई होप ऑल ऑफ यू नो दैट it's very basic, that if I have x to the power n, its differentiation will be n x to the power n minus 1. If I have a constant, its differentiation will be 0. If I have constant multiplied to a function, its differentiation will be constant into derivative of the function. If I have sum of two functions, its derivative will be differentiation of first plus differentiation of second. If I have product of two functions, its derivative will be first function into second as it is plus second function into first as it is, derivative. If I have the quotient, right? So if I have fx by gx, as long as this gx is not equal to 0, then its derivative will be differentiation of first, second as it is, minus differentiation of second into first as it is upon second whole square, upon second whole square. Then the most important in economics is the chain rule. So if I have y as a function of gx, right, and I have to find how y changes as x changes. So f is a function of g. G is a function of x. So you will first differentiate with respect to f. The function f will be differentiated, and then the function g will be differentiated. And this is called as the chain rule. Then if I have an exponents, its derivative remains as it is. If I have a constant to the power x, right, then its derivative will be ax ln x, sorry, ln a. If I have ln x, then its derivative will be 1 by x. And if I have log x to the base a, ln means its base is e. But if I have log x with base a, then this will be 1 by x ln a, right? So these are some of the derivatives that you should know. Now, apart from this, you must know how to do concavity and convexity of function. So if the double derivative is negative, concave, double derivative is positive, convex, right? And then they may ask you about the Taylor approximation. So in Taylor approximation, fx is approximately equal to f of a plus f dash a x minus a if it is a linear approximation. And if it is a quadratic approximation, then you have fx is approximately equal to f of a plus f dash a x minus a plus f double dash a by 2 x minus a whole square. Right? So sometimes they may ask you about the Taylor approximation also in exam, and that is important. Okay. We have already seen a lot of differentiation while doing microeconomics. माने हमने marginal product और ये सब already निकाला है. So it's not a new thing. अच्छा, okay. Let me know once it's done, huh? That's also fine. I mean, you can know that approximation also, but Taylor is usually more asked in exam. Acha, okay. Let me know once it's done, huh? ठीक है. So let's do some questions now. So you're given fx is equal to x minus 3 mod plus x minus 1 whole square. Find value of x that minimizes the function. Give it a try. Take a minute. Try to do this yourself. Just open the absolute value window, huh? Okay. How about others? Hmm. Okay, let's try. So if x is greater than 3, function will be x minus 3 plus x minus 1 whole square. This will be x minus 3 plus x square plus 1 minus 2x, x square plus minus 2 minus x. Differentiate the function 2x minus 0 minus 1 equated to 0, x is half. Double differentiate the function, you get 2, which is positive, right? So we will go ahead and we will keep it here for now. Now let's go ahead and let's check what happens when x is less than 3. If x is less than 3, then my function, if I open this up, this becomes minus. We'll come to conclusions later. We just need to solve this mathematically first. Minus of x minus 3 plus x minus 1 whole square. So I go ahead and I get minus x plus 3 plus x square plus 1 minus 2x. I get x square minus 3x plus 4. I differentiate the function. I get 2x minus 3 equal to 0. X is equal to 3 by 2. I double differentiate the function. I get 2 greater than 0. So this also represents minima and this also represents minima. Now, look that here I had assumed that x should be greater than 3. X should be greater than 3. But the answer I am getting is x is equal to half. It's not greater than 3. So it is a negation. It is not correct. The answer I am getting is half. And I have assumed that x should be greater than 3. So ये गलत हो गया. Now if I look here, x should be less than 3. And I am getting x as 1.5. This is fine. Now let's go ahead and evaluate what happens if x is exactly 3. If x is exactly 3, and if I have this function, if I put x as exactly 3, then this will become 0. Right? I can directly find the value. मुझे कुछ करने का जरूरत नहीं है. And I will go ahead and I will get the value of the function as 0 plus 3 minus 1 whole square, 2 square, which means 4. So at x equal to 3, the value of the function is exactly 4. And what is the value of the function when x is 3 by 2 or 1.5? So value of function at 1.5 will be 1.5 minus 3. I'm putting it in this one, 1.5 minus 3 in absolute value plus 1.5 minus 1 whole square. That means it will be 1.5 plus 0.5 whole square, 1.5 plus 0.25. This will give you something as the answer. So you notice that here, yes, the least value in the three cases that we took, less than, greater than, and equal to is coming here, 1.75. So anyone who has answered it as 3 by 2 is correct. How did you get 2 by 3 here? And so many people? How are you getting 2 by 3? Is it clear now? Any doubt, anyone? Very basic question. We cannot afford to do wrong in such questions. Okay, write down the next one. A very commonly asked question. Evaluate. Limit x tends to 0, derivative of x square e to the power 1 by x. Do it. Everyone solve it. I'll give you some options. 0, ln x, e to the power x does not exist. Okay, good. All of you are right. So if I differentiate this, differentiation of first function, second as it is, and then you differentiate the second function and hold first as it is. Okay, so just do that. Differentiation of second function. Use chain rule. So differentiation of e to the power 1 by x is e to the power 1 by x into differentiation of 1 by x, which is minus 1 by x square, into first function as it is. Right? Now, this and this cancel out and you get 9. This one and this. Now, what's the question saying? The question is saying we need to go ahead and we need to evaluate the limit of this. Limit at as x tends to 0. Now, here is the interesting fact, right? So, you can only understand this fact if you know how to go ahead and how to plot the e to the power x function, right? So just think about exponential functions. How do you go ahead and how do you make these exponential functions? If I were to plot e to the power x, this would have been like this. This is e to the power x function, right? Can you tell me how e to the power 1 by x function will look? Anyone? Will it be a mirror image? Will it be downward sloping? How e to the power 1 by x will look? Did anyone try that? Okay. So for that, you just think about what happens when, to plot the function e to the power 1 by x, you just think about how this function will act at x equal to 0. So if I just go ahead and if I put 0, anything by 0 is infinity, isn't it? Now e to the power infinity should be infinity. So which means that here there is something fishy because I'm getting infinity, which means there might be some asymptote. I have to think about it. And how can I think about it? Well, try to go ahead and try to take two numbers. 1, 0, positive, but close enough to 0. Man, if I take 0.0000000000001. So I'm क्योंकि यहाँ पे infinity आया, I should be looking at the two sides of 0 कि 0 के right hand side पे क्या हो रहा है और left hand side पे क्या हो रहा है. So if I approach 0 from the right hand side, माने if I take a number which is positive but very very close to 0, तो यहाँ पर I will get e to the power 1 by 0.000000000. माने it is a positive number. राइट. तो एनीथिंग जब हम एक नंबर को एक बहुत स्मॉल नंबर से डिवाइड करते हैं, दिस इज अ वेरी स्मॉल नंबर. So when we divide a number by a very small decimal number, we assume that it approaches infinity. वो बहुत बड़ा नंबर निकल के आएगा. 1 divided by 0.000000001, this will be a very big number, one with many zeros. जितने zeros यहाँ हैं उतना zeros होगा when you will divide this number by 1. So mane this will be very very big number, mane infinity. So this will be going towards infinity. E to the power infinity is infinity. But if I take any number close enough to 0 but less than 0, mane if I take a negative number, जैसे if I take 0.0999999, say 0.00000000001 with a negative sign, suppose. That means very close to 0. 0 के पास ही है, but it's a negative number. So when I will do 1 by minus of this, तो ये एक negative number देगा, isn't it? So this will give me e to the power minus of this number, minus of whatever this number is. And whenever the power is negative, you take things and reciprocate them. So this will be nothing but 1 by e to the power 1 by this. And ये तो infinity है. So it will be 1 by infinity. माने this will approach anything by infinity is 0. This will approach 0. So this is very interesting question. When I try and I approach this function from the left hand side, क्योंकि negative power है तो वो denominator में चला जाएगा तो वो 0 की तरफ जाएगा. The function will approach 0. But when I approach this function from the right hand side, the function will approach infinity. The function, when I approach 0, it will go towards infinity. And when I go ahead and when I approach it from here, it will go towards 0. Right? So this means that this y-axis, this will act as a vertical asymptote of this function. And this also means that the limit does not exist. क्योंकि when I say limit x tends to 0 plus e to the power 1 by x, I get infinity. But when I say limit x tends to 0 minus e to the power 1 by x, I get 0. Now holding this important information, homework for all of you. I will not do it in class. I have given you enough hint. Homework, plot e to the power 1 by x. It's a homework for all of you to plot this. ठीक है? Okay. Yes. Do you want to understand this again? Is this a doubt or you only how it is 0? See, I have e to the power 1 by x, but x is a negative number. So if I tell you, because it's close enough to 0 but less than 0. So if I tell you, how do you write x to the power minus 2? You will tell me, ma'am, this is nothing but 1 by x to the power 2. How do you write e to the power minus x? Ma'am, it is nothing but it is 1 by e to the power x. So when you have negative power, it goes in the denominator. You reciprocate it. That is exactly what is happening here. Since I am taking a number close enough to 0 but less than 0, mane, I am taking a negative number. So if I am taking a negative number to make that positive, I can say it will be 1 by e to the power 1 by x. Now you can take x as its absolute value, a positive value. See, minus 2 became 2. Minus x became x. So now this is 1 upon e to the power 1 by x. And I know that e to the power 1 by x, we proved that this is approaching infinity. We did that, right? So it is actually 1 by infinity, which means anything by infinity is 0. So it goes towards 0. Is it making sense now? Please ask if there is any doubt. It's a very commonly asked question.